Okay, good morning. So we continued the lesson. We started very important formulas in trigonometry, and that was addition and subtraction formulas. So if you don't mind, let me write them here. We want to just solve a little bit more diverse examples that somehow is related to this topic. Okay, so we remember we had 4 formulas. So now let me write them in the order of we usually write. We usually start with sine, but for the proof, if you remember, I started with the cosine, yes? So that was sine alpha plus beta. This is equal to sine alpha, sine of the first one. If I want to calculate the sine of the sum of 2 angles, then I can actually write the sine of the first one multiplied by cosine of the second one, plus the other way around, meaning sine of the second one, cosine of the first one. Yes? So that was the formula that we discovered for this combination. Of course, naturally, the second one is what happens if I have the difference of 2 angles. That would be exactly the same thing, but the sign will change to a negative sign, yes? So number 3, we also had similar formulas for cosine. So cosine alpha plus beta. So here I have cosine of the first one times cosine of the second one. And if it is addition, we have subtraction, sine of the first one, sine of the second one. And finally, we had 4 cosine of alpha minus beta, which is cosine alpha, cosine beta, plus sine alpha, sine beta. So these are the formulas that we learned last time, and we solved very simple examples related to this. So these are called addition and subtraction formulas. And then we also discovered another type of formulas, if you remembered, under the title of the double angle formulas, yes? So we also discovered that what happens if I have sine, let me write 2 theta this time. Okay, you remember something like that? So this becomes 2 times sine theta. So sine of 2 times an angle is equal to 2 times sine of that angle, but multiplied by cosine of that angle as well. So these are called, this is one of the double angle formulas because you have the double angle and you want to see how it works. For cosine, we had similar arguments, so we had similar formulas. So it is cosine theta squared minus sine theta squared. But for cosine, we could eliminate cosine in favor of sine. We get another formula, which is this one. Yes, we can eliminate sine in favor of cosine. We get another formula, which is this one. So these are called double angle formulas. And I always tell you that behind any math formula, there is a message that you need to learn, yes? So for example, the message of this formula is that cosine of 2 times an angle is cosine squared of that angle minus sine squared of that angle, yes? And then, for example, let me review. How did we get this formula? Do you remember? The proof of these are actually a little bit involved, so we spent more or less big part of the last session to prove them. But going from these formulas, for example, to these formulas are more or less straightforward. Do you remember how we did it? How we convinced ourselves that this formula is valid? Don't forget, yes? Because actually you answered me, Abdul Rahman, yes? You told me what to do. So how should I, for example, prove this one? Yes, so how, for example, let us review. If you want to show why this is true, I would say that, okay, sine 2 theta means what? Means sine theta plus theta. Yes, do you doubt this? Theta plus theta is another name for 2 theta, yes? So I wrote this in this form, but what is the benefit? Because immediately you see that the first formula in this list is applicable here, if I give the role of alpha to theta and the role of beta to theta again. Yes, so then I write the right hand side. So it becomes sine of the first angle, which is theta, multiplied by cosine of the second angle, which is again theta in this case, plus sine of the second one, multiplied by cosine of the first one. Yes, and then of course this expression and that expression are the same. I have two of them. When I add them up, it becomes 2 sine theta cosine theta. And that's exactly the formula there, okay? So in principle, double angle formulas are not a very fundamental formula. They are not fundamental because you can derive them from these addition and subtraction formulas. Yes, is that understandable? Okay. But for example, I told you that just understand the message behind any formula. For example, if I write sine of an angle x, do you think this is true or not? 2 sine x over 2 cosine x over 2. So if you see this, do you think this is true or false? That's also true, yes? Because now, what can I see that this is sine of an angle? I can visualize it as sine of 2 times an angle. Which angle? X over 2, yes? So sine of x and sine of 2 times x over 2 are the same, yes? Because 2 times x over 2 is the same as x. But now you can give the role of theta to this expression, to this angle, and then you can use the first formula, yes? So this becomes 2 sine theta over 2 multiplied by cosine theta over 2. So, what did I do? So, not theta over 2, theta. Yes? And then theta itself is x over 2. So I take it off and put x over 2 there, yes? So I don't want you just know this formula. So if you need sine of any angle, can be written as 2 times sine of half of that angle, cosine of half of that angle. Yes? For example, if I ask you to write something, if necessary, I'm not saying that this is always needed. So if I write 3 theta over 4, can I write it as 2 times sine cosine? Yes? So what can I write? Here, this is playing the role of my angle. So this becomes 2 sine of which angle? No. Why 6? We divide by 2. No, you are multiplying by 2. This is 3 theta over 4. Yes? Yes. So sine of this angle, if needed, I'm not saying this is always needed, but if you need, you can write it as this. At least when you see it, you need to understand this is true. Yes, is that right? So you should be comfortable with these kind of gymnastics between these angles. So whenever you see one formula, this, and that, and or the same formula, okay, but for different angles. Is that clear? Okay, I want you to know this about it. So I think it's a good idea if I write something for comparison here. So do you remember? So there are some combinations that they should look familiar to your eyes when you are working in trigonometry. Probably the most fundamental one is this one. What is the answer? So this combination should look familiar to your eyes. So that is one. Okay. And now something here I want you to understand. If I write it in this order, let me change my color. So this was the previous lessons, but let me write something here for you so that you can compare them. Yes? So what is the answer now? You see here, it is the same combination. If I have addition, an answer becomes 1. If I have subtraction, the answer becomes cosine 2 theta. Yes? It is good to have them somewhere so that you can compare the formulas. Okay. Then from this formula, do you remember we had two other formulas? One was 1 minus cosine to the power of 2 theta. What is the answer here? From the first one. It is sine squared theta. Yes? And then 1 minus sine squared theta is what? Cosine squared theta. So that is exactly the same formula. But now look here. If I have a 2 here, instead of having 1 here, then instead of having 2 up there, I will have 2 down there. Yes, so let us write this one here as well. So these combinations, you need to know a little bit about them. Okay, so if you have this combination rather than that, this is a little bit new. This is the new formula, not the old one. But instead of having 2 top up there, you see that I will have 2 down there. So these formulas are good if you remember them pairwise. For this one, we don't have something that you get confused. Okay, so this is something like that. Okay, but let me also write something else for you here. So if you start from here, okay, if you start from here and here, let me write this formula here down there. I have cosine 2 theta is equal to 1 minus 2 sine theta to the power of 2, okay? So if you don't mind, let me move this to the left and move this to the right. So what happens? It becomes 2 sine squared theta is equal to 1 minus cosine 2 theta, yes? And I divide by 2. So sine squared is 1 minus cosine 2 theta divided by 2. So that is also another famous combination that you need to remember. At least you need to know about them. If you forget the details, you can look at the formula sheet. But these formulas that I'm writing here are not included in the formula sheet. They probably expect you to be able to go back and forth with this simple algebra yourself. So what I want to add this formula with the green whiteboard marker there, yes? So here you see sine theta squared. On the one hand is this, on the other hand is this. These are very important formulas. These are not new formulas. Essentially, all these formulas that I'm writing down relies on these 4 fundamental ones. But I'm trying to write them in a different way so it is good to have this table somewhere in your notebook. So you see, sometimes you will need to write sine theta squared in this form. Sometimes you might need to write it as the double angle. So that you can use this formula, yes?
If we have in the second formula, the green one.
Oh, sorry, yes. I was stupid. Thank you very much.
If we have a minus angle as theta.
What?
If we have a minus angle, the negative angle, can't we like take the minus out on the sign?
Yes.
And it becomes positive, so it becomes...
No, it doesn't become positive because sine minus theta squared is minus sine theta, as you mentioned, but squared. Then it becomes positive again. Yes, but you are right. So this is right, but power of 2 is also there. Okay, so I was very sorry writing just 2 theta. Okay, so if you don't mind, let me change the battery here. Could you find the formula? So you see, for this one, I started from these 2. For the next one, I will start from these 2. Okay, so what can I do now? I can write it here for you. So another formula for cosine of 2 theta is equal to what? 2 cosine theta squared minus 1. So this time, let me move 1 to the other side. It becomes positive 1. And let me divide by 2, yes? So this becomes 1 plus cosine 2 theta divided by 2. It becomes what? Cosine 2 theta. And this is what I want to move in front of the other one, okay? So this becomes what? 1 plus cosine 2 theta divided by 2. And they are very similar, you see? Okay, but both of them are related to cosine 2 theta. Okay. Another thing that I want to mention is that sine of a theta, this combination is also famous in trigonometry. If you have the product of sine and cosine, how can I combine it into one single sine? This is a famous combination. You need to remember these famous combinations. If you forget the details, you can find them in the formula sheet. But yes.
You can write cosine theta as sine 180 minus theta.
Okay, but then it becomes the product of two sines. I want to write it as one single sine. Which formula on the board is useful? So this is why I'm saying, if you don't understand exactly what is going on, just having access to the formula sheet is not that helpful. Yes?
The first formula of the number
Yes, yes. So how should I, this combination appears here. Yes? Sine theta, cosine theta. How can I write this? Divided by 2. So this is something I want you to know. So this, if you have the product of sine and cosine of the same angle, then you can write it as 1/2 sine of 2 times that angle. Yes? So this is something I want you to know. Okay, so let me also add that formula there. I changed my color. So if you see this combination, sine theta, cosine theta, it should look familiar to your eyes. 1/2, and then you have to write sine 2 times that angle. Okay, so if you don't mind, let me multiply this by 2, multiply it by this 2. So then I would write some other formula. These are not other formulas, but I want you to remember these two combinations are also famous, okay? So for this one, this becomes 2 sine squared of theta. This becomes 2 cosine squared of theta. Again, don't interpret them as 2 theta and theta. What is the mathematical message behind that? Whatever angle appears here, half of it will appear here. So it doesn't matter if it is 2 theta and theta or theta and theta over 2. Okay, so it doesn't matter. Anyway, so you will only get these formulas in the formula sheet. But sometimes it is good to know that you can do these gymnastics on these formulas to write them in a different way, which is more suitable for the problem that you're solving. Okay? Any questions so far? Okay, so let us try to solve. So you remember that the main topic that we learned in trigonometry in Math 4 was trigonometric equations and trigonometric identities. Okay, so now we expand our formulas, but we can review the same topics again. So now these formulas enable us to solve harder equations and to prove harder or more complex identities. Okay, so we have to practice on that as well. So which is part of the book. Okay, so let me give you an example here. So example. Let me start with identities first. Prove the following identities. Okay, so number one, let me ask you to prove this. The sine of u, so let me write x and y, because sine of x plus y multiplied by sine of x minus y, we want to prove that this is equal to sine of x squared minus sine of y squared. Okay, so we will not be able to solve to prove this identity because it needs new formulas. So we want to show that if I have two angles, x and y, if I add them, take sine, and I subtract them and take sine, and multiply the numbers, this becomes equal to sine x squared minus sine y squared. So why is that? We want to prove this. Do you have any idea what to do? So let us review things we learned for identities. In identities, we have to start from one direction and do some valid calculations and reach to the other side. And usually I told you that it is better to start from that side which is more involved, or at least you know something about. So which side do you prefer? It seems to be left, because it is very clear that I can immediately apply those two formulas. And by the way, here I am teaching you this, so you know that my example is somehow related to my lesson today. But in the national exam, you need to know it well enough to, by looking at the question, remind yourself about the topic which is related to that question. Okay? So how I think that this is related to this new lesson? Because I have the sign of addition and sign of subtraction. So this reminds you that this might be relevant to this new lesson. So I will start from the left-hand side. Okay, if you recognize that this is the lesson for addition and subtraction formulas, then you page the formula sheet and find the corresponding formulas. Okay, this is on the board for the time being. So what should I write? Instead of that one, I write sine of the first one times cosine of the second one plus sine of the second one multiplied by cosine of the first one. Which formula did I use here? Number one, yes? And then I will use number two, yes? Okay, then what? It is not that easy probably to predict what should I do to reach the right-hand side, but there is one natural step that usually you should have enough experience to take, okay? So what is that step, do you think? Does this product somehow reminds you of some pattern or something? Yes? Which pattern is that? Conjugate pattern, yes? Because I have two numbers, okay? Once added, once subtracted, and then I want to multiply them. So that is the conjugate pattern. So what happens? It becomes the first one squared minus the second one squared. Okay, now what can I do with this power 2? Because that's a product, a times b to the power of 2 is what? Is a squared times b squared, yes? So I can write it as sine x squared cosine y squared. Similarly here, okay, how do you evaluate this? Do you think it is successful so far? It seems so, yes? Because if you look at the right-hand side, you need sine x squared, it appears. You need sine y squared, it appears. So I wouldn't say it was a waste of time so far. But of course it is not complete. How should I do that? By looking here, I see that I do not have any cosines involved. Yes? Here I have two cosines involved. I somehow want to get rid of them in favor of the other one, sine squared of x and sine squared of y. So which formula now becomes useful? Yes?
Can you use one of the first ones, the same formula that is negative?
Here?
Yeah.
No, none of these formulas is probably useful. Do you know why? None of them is useful, apparently. Or if you want, you have to defend yourself. At least I don't see it, yes? The reason is that none of them has a power of 2 on it. So you cannot say that if I put a power 2 here, then I can put a power of 2 here. Okay? So that rule is not there, yes? Yes?
Why don't you use 1 minus sine squared?
So you mean these ones, these black ones?
Yes.
Yes? One of them is useful here. This is useful if you want to get rid of sine in favor of cosine. This is useful if you want to get rid of cosine in favor of sine. Okay? But here I want to get rid of cosines. So what I do, I copy and paste this one, which I need. But I don't need this, I want to get rid of it. So what should I write?
1 minus sine.
1 minus sine y squared. Do you agree? And it was not hard because in front of this one, we have two formulas. I think that you are not confused either I should use this one or the other one. Yes, the other one is useless here, even though that's true, because it brings in 2 times x, which is not 2 times y, which I don't need it. So then I think you know what to do now. So I would write this one again. So I want to get rid of cosine x squared. What should I write, everyone? 1 minus everyone, please. Yes. Yeah, be active a little bit. Okay. Now what should I do now? A very natural thing to do. At least you should be relieved here because what you need is what you have. You only need sine x squared, you have it. You only need cosine y squared, you have it. But it's a wrong combination. So what should I do now? What should I do? Hello? Multiply, yes. Don't hesitate to say multiply, yes? So then I would say this, and then I multiply this in, which becomes minus sine y squared, but next one, negative multiplied becomes positive, yes? Everyone happy? Yes. Then what happens, you see that is very simple. This combination and that combination are the same. One of them is negative, the other one is positive. So this one and that one are totally gone. And what is left for me is sine x to the power of 2 minus sine y to the power of 2. And that's exactly equal to the right-hand side. So I started from the left-hand side. Little by little, I reached the right-hand side. So that's the proof of this. Okay, I will give you one very similar one, but I want to wait for you, okay? So we don't need that. So number 2, I want to write something for cosine. Okay, so let us write cosine x plus y multiplied by cosine x minus y is a little bit different, of course. Cosine x to the power of 2, but not minus cosine y, minus sine y squared. Okay? The idea is very much similar to the previous one, but let us see if you understood what's going on. I want to wait for you, okay? 5 minutes. Okay, could anyone solve it? No. So it shouldn't be hard, yes? Let us see if you couldn't, why? Okay, everyone, so I think that is very similar to what you see on the board, yes? So I start from the left-hand side, of course, which formulas now become suitable? Number 3 and 4, yes? So what can I write? I can just copy and paste those formulas, but of course, instead of alpha and beta, I have x and y. So this becomes cosine of the first one times cosine of the second one. I am using formula number 3. Okay, I replace alpha with x, I replace beta with y. And then it becomes minus sine x, sine y. And this one will be exactly the same with positive sign. Okay, so the next part, the next step is also clear. That's a conjugate pattern again, yes? So this becomes the first one squared minus the second one squared. But then, of course, you can write it as the first one squared times the second one squared and minus the same thing for this one. Here you have to decide, yes? How should you decide? You need to look at what happens on the right-hand side. On the right-hand side, this is needed, so keep it. This one is also needed, so you have to keep these two. But you have to get rid of the other two, yes? So why you couldn't solve it if you couldn't? So what is the problem there? Because that's very simple, isn't it? So I keep cosine x squared. I keep sine y squared. But I want to get rid of this one. And I want to get rid of this one. Okay? So what can I write for cosine y squared? It's on the board, yes? Cosine of an angle squared can be written as 1 minus sine that angle squared. This can also be written like this, but hopefully you realize that this is not useful in this context. Yes? So what you write 1 minus sine y squared. Yes? And for this one, what do you think I will write? Cosine, exactly, x squared. Yes? And then let us multiply. So what happens? It becomes cosine x squared minus cosine x squared sine y squared. But here you have to be careful. I multiply sine squared here, but a minus sign also here. So this becomes minus sine y squared. The next one becomes positive, and this will be also multiplied. So it becomes cosine x squared sine y squared. Yes? And now you see that this one, oh sorry, this two should be written here. So this one and that one are cancelled. And that is exactly what I need. Yes, and that's equal to the right hand side. Yes? Any questions? Okay, so let me give you one more. This is similar, this one that I write here is very similar to the one in the book. Okay, so let me write, we want to prove cosine 3x is equal to 4 cosine x to power 3 minus 3 times cosine x. Okay, so let me change the number here. So you see, I hope that the idea, so this is very similar to this. So that the left-hand side is exactly what is in the book. The right-hand side, I changed it to make it a little bit more challenging. In the book, it's a level 2 problem. You can consider this as a level 3 problem, okay? But the left-hand sides are exactly the same. Okay, so I want to hear from you because that is the situation that you will face. I solved 2 problems and the formula sheet is in front of you, but you are getting a new question. That is the same thing that will happen in the national exam, okay? So how do you think I will solve this one now? Anyone else? Yes?
Maybe you could use the third formula with cosine alpha plus beta, but you alpha is x and beta is 2x.
Yes. Isn't it natural? This idea should be natural because it's on the board, yes? When I wanted to prove sine 2 theta, I wrote 2 theta as theta plus theta. You might think that I will write cosine 3x as cosine x plus x plus x, which is true. But it is a useless true, yes? Why is that? Yes, it involves 3 angles, but the formulas that I have involve only 2 angles. So writing 3x as x plus x, either though it is true, even though it's true, is useless. So I would follow yours. So I will start from the left-hand side here, and by the way, this is a little bit deviation. The right-hand side seems more complicated than the left-hand side, but there is no way that I can understand how to go from this one to that one, so I start from here. So that was sometimes exceptions, yes? So I would write cosine 3x as you told me. You told me write 3x as x plus 2x. Yes? I mean, it is not hard to understand this step if you understood the proof for 2 theta. So the book is asking your understanding. If you understood how I got that, can you do something similar to get something new? Okay, so how can I continue? Which formula do you think will be suitable in this case? Formula 3, because now alpha is being played by x, beta is being played by 2x, yes? So what can I do now? I just use the formula, so it becomes cosine of the first one, cosine of the second one, and then minus sine of the first one, sine of the second. Yes? Okay, I want to hear from you again. Do you have any proposal here? You need to have an eye on what you want to get at. So you need cosine. So this is good to have. But this is not good to have because it is cosine of double angle formula. All the angles are just x. This is not good to have. This is not good to have. So we need to find a way for them. Yes? So I would say that let us keep this for the time being. What is your suggestion for me for the second term? Do you have any ideas? You see sine x, there is nothing I can do about sine x, yes? But for sine 2x, I probably can do something. It's on the board. What can I do? Yes?
Like sine x plus
Yeah,
x.
the first formula on the right-hand side, sine 2 theta. But theta is being played by x now. So what can I write? I copied and pasted this minus sign. Sine x is copied and pasted. But instead of that, I can write 2 times sine x cosine x. You might ask yourself why this is useful. You can see why it is useful, because instead of having 2x, which you don't see on the right hand side, I have x's. So I would say it is reasonable to think in that way. Do you understand what I'm doing? Yes? Okay. Now, for this one, hopefully you decided not to do anything. But then here, you have 3 options available rather than 1 option. Which formulas you see? Formulas here, yes? Cosine of 2 theta can be written in one of these alters, yes? So how can I do that? Which one is suitable? Yes?
Maybe 1 minus 2 sine squared theta.
No. Yes?
The last one.
The last one, why? Because here you are eliminating cosine and bringing sine in. But you don't have any sine on the right hand side. Why should I even try it? Yes? If you use the first formula, you are bringing both sine and cosine in, but I only need cosine on the right hand side. So there's only one option left if this problem is supposed to be solved using this method. So what can I write here now? Instead of the first one, I write 2 cosine x squared minus 1. Is that understandable? And what next step is? Probably the next step is a little bit natural, just to multiply and expand things. So what happens, this becomes 2 cosine x to the power of 3 minus cosine x. And this is a multiplication, but sine x multiplied by sine x. So I put 2 here. Sine x times sine x is sine x squared cosine x. Okay. In the book, this is the problem in the book somehow. So might be they have asked you to prove this to this one. This is a level 2 problem. Okay, because it's finished here. But I want to continue a little bit more. Okay. So what is your suggestion now? If you have listened to what I said, it should be very simple for you to know what to do, because you need only cosine, but you have a mixture of cosine and sine because of this unfortunate term. So what should I do? Everyone, what should I do? Yes, please. X squared. Yes, that's it. So what I do, so it becomes 2 cosine x cubed minus cosine x, and then I put a minus 2. So don't be careful not missing points because of miscalculation. So I copied and pasted this one, copied and pasted, and I want to take it off and write this, yes? And the rest of it is just again multiplication. It shouldn't be hard. So let us continue. But be careful here, minus 2 is being multiplied from the left, cosine is being multiplied from the right. So let us just do them in one go. Minus 2 times 1 cosine, so it becomes minus 2 cosine. Agree? The next one, these two are being multiplied here. Minus 2 times this one becomes positive, and this one times that becomes the third power, yes? Okay, happy? And then I think you can see this problem is finished, yes? Because this one and the very last one can be combined. What's the answer? 2 of them plus 2 more. So it becomes 4 of them. And here I have minus 1 cosine. I have minus 2 cosine. So it becomes minus how many cosines? 3 cosines. And that's exactly equal to the right answer. Yes. So that's also one type of problem. I will write number 4, but I will not solve it, so you can do it at home whenever you have time. It's very similar to that one. So let me write number 4. We don't do it in the lesson, okay? So number 4, I want you to do something similar for sine of 3x. And the answer will be 3 sine x, very similar, but a little bit differently. Okay, I really want you to do it at home. So if you see, this question that I wrote here for you is very similar to this question. Okay, so as I told you, even they consider it level 3 problem, so it might be anyway. But let us try to solve some of these questions together. So let us try to solve this level 3 problem from the book. Okay, so let me make it nicer. Yes, so here, we want to solve this problem. I consider this hard because you really need to know what to do, okay? I will write this here on the board, but let me keep the formulas so that if you need them, you can use it. Do you have any idea what to do? Yes?
You can write tan x divided by 2 as sin x by 2 divided by cosine x divided by 2.
Okay.
And then sine x is double angle of x divided by 2. So we can write it as 2 sine x cosine x.
No, 2 sine x over 2 cosine x over 2.
Oh, yeah.
Because this angle is x. Yeah, you are right. But if you don't mind, that's good. I will start from a little bit complicated one here. Okay, so you started from here. It doesn't matter. But I will prefer to start from the right-hand side. But you are actually on the right track. That's good. So you see here, there are different ways to look at this problem. So I will copy and paste the denominator. But you see here, what I have, this is the only problem here because this is already half the angle. And on the left-hand side, I have half the angle, half of the angle. But here, I have just the full angle x. So this somehow should probably motivate you, if possible, to write this in a way that x over 2 appears. Okay? If you don't have this strategy, that is just random calculations. And it doesn't usually work. So you need to have a strategy. This is my strategy. Might be it is wrong. If it is wrong, then I realize it in the middle, I cross it over and try to find another strategy. But just random calculations does not work if you don't have a strategy to do. So that was my strategy. I realized that, okay, the left-hand side is expressed in terms of half of the angle. On the right-hand side, this part at least is expressed in terms of half of the angle, but this is not half of the angle, okay? So I want to get rid of this x in favor of half of the angle. Then hopefully, I don't know which you use, so you can see that sine, and that is why exactly this formula is in the formula sheet. But then you need to realize yourself that you can change to theta to x, but the price that you have to pay is to write x over 2 here. This you need to understand yourself, okay? Is that understandable? So here, I would say this becomes 2 sine x over 2 cosine x over 2. This is why I emphasize so much, yes? Because this formula, you get it in the formula sheet. If you don't understand what you're doing, might be you will not be able to see that this formula can be used here in this form. Is that part understandable for everyone? Yes? Okay, and then what happens? The rest of it, this is the only new lesson. Now it becomes the old lesson. Even some part of it is in Math 3C. So what can happen to these 2 and that 2? They are gone. Gone means 1 is left. Yes? And then what more? 1 cosine x, what is the meaning of cosine squared? It means cosine x over 2 multiplied by another cosine x over 2. So one of them will cancel this one. So this is gone. How many is left? This one is left. And then what is left? A sine x over 2 is left in the numerator. What is left in the denominator? Cosine x over 2. But then again, this is a very old lesson, that if I have sine of an angle divided by cosine of the same angle, this can be written as tangent of that angle. And that's exactly equal to the left-hand side. So here we started from the right-hand side, we reach the left-hand side. So you see that you really need to know, if you want to be able to solve these problems, you really need to know how to use them, to use the formulas problem. It's not just enough to have the formulas. Okay, any questions? Okay, solve the following equations. Equations, yes? So number one, I will pick it exactly from the book. So that is the first question. Sine x, cosine x is 1/4, yes? So we want to solve, be careful, we want to find all possible values for x. This is not an identity. Okay, so do you have any idea what to do? So you see, that's why I'm saying I was talking about this combination in trigonometry, the product of sine, cosine of the same angle should look familiar. If it looks familiar, then you know what to do. So what should I do now? Yes?
If you multiply both sides by 2,
Yes?
then you can see then 2 sine x, cosine x.
Yes. So I can use this formula, yes? You see, this combination is familiar. This combination is appearing here, but you lack a factor of 2, okay? If you had a factor of 2 here, then that was exactly the formula. You don't have that factor of 2, okay, but you can make it yourself. Why? Multiplying both sides by 2. So what happens, this becomes 2 sine x, cosine x, and on the right-hand side it becomes 1 over, yes? Is that understandable? Now, what can I write for this one? Sine 2x. And then, this is very old lesson. Yes? Sine of a sine, do you remember? Sine of this equals to a number. So there are two options, yes? Here, let us write it in radians from now on. If it's not mentioned, let us do it in radians. So this becomes what? Do you remember? Sine inverse of k plus 2n pi. And the other one was 180, which in the radian mode is pi. And then again 2n pi. Yeah, so something like that. So here I give the roll of my box to this. And I write the answers, yes? So there are two options. Number one, 2x is what? Do you remember? So you don't need to remember, of course, the formula, but the number 1/2 should look familiar for you, okay? What is the angle? The angle is 30 degrees, but you need to write it in radians, which is, you should be quick at. So pi is equivalent to 180 degrees. 30 degrees is a sixth of that. So it's pi over 6. So this becomes a sine inverse, which is pi over 6 plus 2n pi. And then you want x, so you have to divide by 2. It becomes what? Pi over 12 plus n pi. N belongs to z. But this is not the whole story. Another option is what? 2x is pi minus this angle you found plus 2n pi. But you need to calculate this. What is that? This is 6 pi over 6, so it becomes 5 pi over 6 plus 2n pi. When you divide by 2, it becomes 5 pi over 12 plus n pi. N belongs to z. So I have two group of solutions, each including infinitely many solutions in it. Yes, is that clear? Okay, so let me wait for you to do the second one for me. Because you see, there is nothing that I can teach. I have to bring more examples to increase the skill, okay, your skill. There is nothing I can do, okay? So, in principle, you should be able to solve the second one yourself. It is a little bit harder, I agree, but let us try to do this. Cosine 2x equals to cosine x minus 2 sine x squared. This one. How do you think now? Anyone else? Do you hesitate to answer? You really don't know which one. Yes?
The answer for it is
No, how should I continue? What is the starting point? I want to solve an equation. Solve means find. I want you to differentiate the difference between identities, and I'm not asking you to prove this is true. I'm asking you to find x so that it becomes true. Okay?
yeah. If you know that 1 minus 2 sin squared x
Yes?
equals cos 2x, then you know that cos x equals 1.
Yes? So you have to write it down exactly. So I don't know how, but you need to practice on that. So he realized that this formula is useful in this problem. Yes? So instead of cosine 2x, he decided to write that one. Why not this one or that one? It's not hard to see, because if you write this one like this, you minus 2 sine squared x will be cancelled. And then you have a simpler equation. But then there is no teacher that can teach you how to understand to do this. Okay? So you need to practice so that you can see the formulas, because there are a lot of formulas here. So you need to realize that. And then you see this is exactly the question in the book. I'm not just bringing it up from myself. So here, the first thing that you do, you write the second option for the cosine 2 theta, but theta is being played by x here, so this becomes simply that. And on the right-hand side, I have cosine x minus 2 sine x squared. Yes? Now you see why that was useful. Because you can move this in your head to the other side, it becomes positive of the same combination. So that one and that one are gone. And what is left for me is 1 equals to cosine x, or cosine x is equal to 1. And this is one of the simplest equations we solved before. Cosine x is equal to 1. Yes? That's a very old lesson. So this is the only thing that you needed in this new lesson. And that is the old lesson now. So do you remember? Cosine of a box equals to k. Do you remember the formulas? So the box is equal to plus or minus cosine inverse of k, plus, let me write it in radians as well, so plus 2 in pi. That's the same story here. So what happens here? X becomes plus or minus cosine inverse of 1 plus 2 n pi. But you know what is cosine inverse of 1? 0. So plus or minus 0 is just 0. So this becomes 2 n pi. As simple as that, you know? Yes? And of course, in the national exam, it becomes a little bit harder because we will be very far away from trigonometry. So you need to keep your memory fresh, very fresh. Any questions? Okay. So let us see. Of course, in the book, they have solved it using degree mode, okay? Which is a little bit deviation, because if they want you to solve it in degree mode, it is better to mention it. So here, I don't know why they have decided to work this out in the radian mode, but the other one in degree mode. Anyway. Okay, so let us see how much time we have. Okay, so let us go and solve some of these problems here. And by the way, I don't know. For example, they consider this a level 1 problem. Let us see if you can solve that, okay? Okay, let me give you time. Might be, according to the level in the book that I see, they shouldn't consider this level 1, but they're considering level 1. Okay, so let us solve the first one. Part A. This is your book. I'm choosing a level 1 question from the book. It's not something that I make it up, okay? Solve these equations. So everyone concentrate on one. Part A. have it recorded. So I multiplied everything by a negative sign. Yes, but now this is exactly the right combination, and then you see it on this line, and that is cosine 2x is equal to -1. Yes, and now that's exactly the formula you see here. This is the box. So the box, which is 2x, is plus or minus cosine inverse of -1, and then plus 2n pi. But cosine of -1, which angle has cosine -1? Do you remember? If you visualize it in your head, of course you have it in the table, but pi. So this becomes plus or minus pi. So 2x becomes plus or minus pi, and then plus 2n pi. But you are looking for x, so you divide everything by 2. N belongs to z. Okay. So that's the answer. But sometimes might be they make it a little bit harder by giving you a multiple choice question and see that what's it. Can I combine these two formulas into one single formula? This is also good to check. Yes, because whenever you have these angles pi over 2 and something like that, then might be this is possible. So where are these angles with the positive sign only? If I put 0, I get pi over 2 here. If I get, I'm considering the positive sign. If I put 1, it becomes 3 pi over 2 here. And then if I get 2, I will go back here. But now if I put minus pi, do you agree I will generate the same points? Because if I put minus pi over 2 is here, then pi over 2 is there. So I'm generating the same ones. So you really don't need to write plus and minus. You can choose either the plus one or the minus one. If it is a question that I ask you to solve and you keep it like that, you will get all the points. But I want you to understand, sometimes they give you multiple choice questions and then they don't put this as one of the options. They put either the positive one or the negative one. So you need that, in that case, you need to understand that is also correct, yes? So these two formulas can be combined into one single formula now. Okay, so what do you think will happen here now? Do we have time, or when do you think the lesson will finish? So I will keep you work on them yourself, but let us just do this one now. They consider this level 2 problem level. Yeah, let us solve one of the level 3 problems here. So we want to solve this equation. Okay, sin x tangent x plus cosine x is equal to 1. We want to solve the following equation. I don't know if they mean it or not, but this is not related to this lesson at all. Okay, it's a level 3 problem, but none of the formulas here is useful. Only the old formulas are useful, so you really don't need something new. So in principle, I would have given you this when I was just teaching the normal equations, yes? Okay, so let us see that. What is your suggestion here? I want to solve, be careful, I don't want to show this is always equal to 1. I want to find those values for x so that this works. Yes, please. Yes, it's a good idea. So let me write this. Sine x, because I told you, if you remember the lesson, what is the strategy in solving any trigonometric equation? There is one strategy only. And that is reduce a given equation into 3 standard forms only, because we can always solve all those 3 standards. Tangents equal, cosines equal, or sines equal. So this is the general strategy behind any kind of solving equations in trigonometry. So what I would do, I have to know how to deal with these expressions so that, but I have a strategy. I want to reduce this given equation into one of those 3 standard forms. And I will do whatever it takes for it, yes? So here, as you said, I will do this, but let us see if it helps or not. Okay, then this sign can be multiplied. If still you have some problems, if I have A and if I have C over D, if I want to multiply this, it means A over 1 multiplied by C over D. Then it means A times C, 1 times D, which can be written ACD. But I want you to be able to do this immediately like that, yes? So this sign is playing the role of this A, this sign is playing the role of this C, and this cosine is playing the role of D. So this I can be immediately write sine times sine is sine x squared over cosine x plus cosine x equals to 1. Then, yes, whenever you have fractions, if you remember the previous, you have to get rid of fractions as soon as possible. So to get rid of fractions, it is not too hard to see that if I multiply by cosine, this fraction is gone. So I multiply everything by cosine. On the left, I have to do the same thing on the right, otherwise I am violating the rules, yes? But then when I multiply cosine in, this cosine and that cosine are cancelled, 1 is left, so it becomes just simply sine x squared. If I multiply cosine here, it becomes cosine x squared. And on the right hand side becomes what? Cosine x. Okay? So now this familiar combination happens. So what is that? 1. And that becomes cosine x equals to 1. And we know this answer. Let me write it in radian mode. So cosine plus or minus cosine inverse of 1. Yes, so let me write it down. And then plus 2n pi. And this is, as you said, 0. So x becomes 2n pi. Yes? N belongs to 0. And nothing was related to this lesson. Might be, instead of having positive sign, if I had a negative sign, the combination that will actually emerges from here will be the difference combination, will be related to today's lesson. But not this one, might be they meant this. Okay, any questions? So I'm just, we will have the quiz next Thursday, focused on addition and subtraction formulas and double angle formulas only. But you see that for being able to do that, you need to know all previous lessons more or less. Yes, please.
I wonder if we have an equation and it says cosine 2x equals cosine x.
Yes.
Is it against the rules to divide everything by cosine and get like 2x
Yes,
equals
yes,
x?
yes. Because cosine 2x, so cosine 2x equals to cosine x. If you divide by cosine x, that's okay. But we just learned that cosine 2x has a complicated formula. It's not just simply pull 2 out. So you cannot do that. Yes? Okay, thank you very much. So